Stand between two parallel mirrors, and you will see what looks like an endless tunnel of light. Our eyes tell us the reflections go on forever, but we have to ask if that perceived infinity has any basis in physical reality. Many of us were taught that dividing 1 by 0 equals infinity, but in mathematics, that operation is actually undefined. It's a point where the rules stop working, creating a result that is less a number and more a glitch in the system. Zeno's paradox applies this same logic to the physical world. To walk across a park, you must first cover half the distance, then half of what remains, and so on. If you only follow the math, the journey requires an infinite number of steps, suggesting you can never actually arrive. But in the real world, you simply walk. You cross the grass and reach the other side in seconds. The physical reality of the park's boundary easily overrides the mathematical illusion of endless fractions. If we can be so easily misled by a simple reflection or a division error, it raises a difficult question. Is our assumption that the universe itself is infinite based on evidence, or is it just another limitation of our perspective? We can scale this same sense of uncertainty up from a city park to the scale of the expanding universe. Imagine the first ancient sailor attempting to measure the size of the Earth using only a ship and the stars. To that sailor, the ocean appears to be a flat, endless plain. Without the technology to detect the subtle curve of the horizon, a closed sphere is indistinguishable from a world that goes on forever. Modern cosmologists face a similar problem. We look into the deep night, and because we cannot see an edge or a wall, we often default to the idea that the darkness is limitless. However, a lack of a visible boundary is not proof of infinity. Our failure to see the edge of the universe may simply be a sign that our technology hasn't yet caught up to the true scale of our surroundings. One way to test the limits of the cosmos is to try and count everything inside it. In mathematics, we have the googol, a 1 followed by 100 zeros. It is a number so massive it exists entirely as a theoretical concept of the human mind. When we compare that number to reality, the results are lopsided. The total count of subatomic particles in the observable universe is estimated at 10 to the power of 81. The entire physical world is a tiny fraction of that mathematical concept. Stars are born and destroyed every day, but even across billions of years, the total amount of matter remains a manageable, countable figure. While our imagination can scale upward forever, the physical contents of the universe do not. Reality, at its most basic level, appears to be a quantifiable and finite collection of parts. If the matter within the universe is finite, scientists should find a corresponding physical boundary. This was the mission of the Planck telescope. It was designed to map the cosmic microwave background, the residual heat signature from the universe's earliest moments. When comparing telescope data to theoretical models, researchers found a 0.4% discrepancy in the size of these temperature fluctuations. This discrepancy suggests that the light has expanded as it traveled through space. It implies that the universe has a positive curvature, meaning that, like the Earth, the fabric of reality eventually curves back on itself to form a sphere. A spherical universe is, by definition, a closed system. It means that despite its vastness, we are living inside a finite, measurable bubble. If the physical world is limited, then true infinity can only exist in one place, within human consciousness. In 2007, this idea was put to the test at MIT during the Big Number Duel, a competition where researchers attempted to define the largest possible mathematical concept. The event drew challengers from Princeton, turning a theoretical debate into a rigorous test of the limits of logic and set theory. The winner was Rayau's number. It is a value so immense that even writing it down would require 10 to the power of 100 symbols. With this, the human mind successfully created a concept that is physically too large to be contained within the finite universe we inhabit. This creates a dangerous paradox. What would happen if we actually tried to manifest this infinite mathematical concept within our finite reality? Imagine trying to record every digit of that number at the absolute speed limit of the universe, writing one symbol every Planck time, the shortest interval of time that can possibly exist. The energy required to record data at that frequency would generate immense friction. After trillions of years of writing, the localized heat would climb toward the Planck temperature, the point where the known laws of physics effectively break down. At this level of heat, the atoms and forces that hold our world together would dissolve. In a very literal sense, the attempt to write an infinite number would melt the finite container of the universe. We exist within a strictly limited reality, yet we possess a mind capable of imagining an infinity so vast that its mere presence would be enough to destroy the world around us.